Let us go ahead and look at converting recursive and explicit forms of geometric sequences. We will convert from recursive form to the explicit form and also from the explicit to the recursive form. So to convert from the recursive to explicit, we're going to generate a sequence of about 4 to 6 terms. We will identify the first term and identify the ratio, and then OK. Right after that, create the formula in the form that is explicit. So we'll start with this example. Let's look at the first term. So f of 1 equal to 2. F of 2 is going to be f of 1 multiplied by negative 4, which is negative 8. F of 3 is f of 2 multiplied by negative 4, which is 32. And then f of 4 is going to be f of 3 multiplied by negative 4, which is negative 128. So our f of n is a, which is 2. This is our ratio right here, negative 4 to the power of n minus 1. So that is our explicit formula. In the second case, we have f of 1 equal to negative 12. F of 2 is going to be f of 1 multiplied by half, which is negative 6. F of 3 is f of 2 multiplied by 1/2, negative 3. And then f of 4 is f of 3 multiplied by 1/2, which is negative 3 over 2. So the explicit form is going to be our first term, which is negative 12 multiplied by, our ratio is 1/2, and then n minus 1. So to convert from the explicit to the recursive, we follow a similar pattern. The only difference is what our final formula is going to look like. This is not required, so f of n is equal to this formula, with the first term is a, and then the succeeding terms to that will be the ratio multiplied by f of n minus 1. So let's come up with the first few terms. So f of 1 is going to be 4. F of 2 is 4 times 3 to the power of 1, which is 12. F of 3 is 12 times 3, or 4 times 3 to the power of 2, which is 36. F of 4 is 4 times 3 to the power of 3, which is 108. So our recursive formula, f of n, is going to look like this. The first term is 4. And what we're doing here is we're multiplying 3 by f of the previous term. This is when n equal to 1, and this is when n is greater than 1.